When I'm trying to write the equation of a rational function, I'm going to start by finding the zeros of it, the x-intercepts. I can see from the graph that I've been given there's exactly one zero, or one x-intercept, and it occurs at the point 1, 0. And so the zeros help me determine what the numerator of my rational function is going to be. Anything that makes the top of the fraction 0 is going to be my numerator. So I know that my numerator must be x minus 1 because the solution to that would mean x is 1. That would make the top of my fraction 0. So that is the one and only piece, the one and only factor that's going to go in the numerator. And I can see that since my 0 passes right on through, it's got an odd multiplicity, so to the first power, to the third power. Remember, if the graph comes and bounces at that 0, it would indicate that you have a double or at least an even multiplicity. Alright, let's move on to the next piece of this. The next thing I would do when I'm trying to write the equation is I would take a look at where the vertical asymptotes are located. So I can see there's one right here at x equals 2. And I see there's a second one. It's not as easy to see, but there is another asymptote at x equals 0. The vertical asymptotes help me determine what the denominator of my rational function is going to be. Similarly to the way the numerator worked, if I want to get x equals 2 as a vertical asymptote, I know one of the factors of my denominator must be x minus 2. Whatever makes the bottom equal to 0 would be a vertical asymptote. And then to get x by itself, I just have a single x. So there's my numerator, there's my denominator. I can start to kind of build my final equation right here. I'm going to say f of x equals, my numerator I'm saying is x minus 1. My denominator I'm saying is x and then times x minus 2, which I guess I could multiply out if I want to, but I don't really want to. And then the final piece of this puzzle is to see if there's any fine-tuning that we'll need to do. And to do that, we have to take a look at what the horizontal asymptote is. Because remember, that depended on what degrees were and various things like that. I can see that this has one horizontal asymptote at the line y equals 0. And so I made a little note down at the bottom that according to the chart we looked at the other day, if our horizontal asymptote is y equals 0, we have to make sure that the degree of our denominator is greater than the degree of our numerator. Okay, so let's go ahead and take a look at what we wrote and see if we need to fine-tune anything or if we're okay the way it is. The degree of my numerator is just 1 because it has x to the first power. The degree of the denominator is 2 because if I were to multiply it out, x times x is x squared. So I can see that this works. The degree of the denominator is greater than the degree of the numerator. So I don't need to do any fine-tuning. This is a-okay. And these problems are so easy to check. All you would need to do is graph this on your graphing calculator. Just be sure you put things in parentheses. For some of these you may need a double set of parentheses, like the bottom may need a double set of parentheses if you're graphing on your calculator. And just confirm that when you graph it, this is what you're seeing. You could even go further and look at your table and make sure things like 1, 0 are in your table. Make sure when you look up your vertical asymptotes, you're seeing error messages in the y column because there can be no graph at those locations. So there's my equation of this rational function.